So firstly it asks for my birthday, so my year is going to be 2003, my month is going to be the 8th, and my day is going to be the 29th. So the first question asked me to create an arithmetic sequence with the first term being my month, which is the 8th, and my second term being my day, which is the 29th. So those are my first two terms, 8 and 29, and I'm going to find T3 by substituting in 3 for n into the general term original equation, modified equation for this example, and I'm going to get T of 3 equals 50, which means that my third term is going to be 50, and I'm going to do the same thing for T of 4. I'm going to substitute 4 in for n and into the general term, and I'm going to get T of 4 equals 71, so my fourth term is 71. The general term I got by substituting 8 in for a, because a represents the first value, and the first value in this series is going to be 8. And I got d by subtracting my t2 value, which is 29, minus my t1 value, which is 8, and I got d equals 21. The sum of the first 100 terms. So I got this, firstly, by figuring out t of 100, because we have t of n in this equation that is required. So I substitute 100 in for n, and into the general term, and I got 2087. And so I substitute that value into this equation into the t of n portion of this equation, and I also substitute in 100 for n and 8 for t1 because it is my first value. So therefore the sum of the first 100 terms is going to be 104,750. So this question asked me to create a geometric sequence with the first term being my month and the second term being my day. So the first two terms, are going to be 8 and 29 because that's my day, my month and my day. And then I'm going to find my my third term by substituting 3 into the general term right here, and I'm going to get T3 equals 105.42, so my third term is going to be 105.42, and I'm going to do the same thing for T4. I'm going to substitute in 4 for n into the general term, and I'm going to get 382.66 as my fourth term. So the general term is going to be T of n equals 8 times 3.63 to the power of n minus 1, and I figured this out by substituting in 8 for a, and because it is my initial value, my t1 value, and I got r by doing t2 over t1, so 29 over 8, and I got 3.63. So it asks, what is the sum of the first 10 terms? So I did sum of s of n equals a times r to the power of n minus 1 over r minus 1, and I basically substituted in 8 for a, 3.63 for my r value, and I got 1,208,368.50. So therefore the sum of the first 10 terms is going to be 1,208,368.50. So this next question tells me that I've been given $5,000 from my great aunt Petunia. If I invest it in an interest rate of my day, which is 29%, compounded semi-annually, which means that my n value is going to be 2. How much money will I have after my month plus 1 year? So it's going to be 8 plus 1, so it's going to be 9 years. And I didn't mention this earlier, but my day is 29, so I is going to be equal to 29%. So I'm going to plug it into a compound interest equation, which is a equals p 1 plus bracket 1 plus I over n bracket to the power of n times t. So I substitute in 5,000 for p because it is the initial value, or and I substitute in for I 0.29 and I change it to a decimal, and I substitute in 2 for n, and I substitute in 9 for t. And as a result, I get 57,209 and 58 cents. So therefore, I will have $57,209 dollars and 58 cents after 9 years. So this question asks me to basically multiply my year, my month, and my day. So I'm going to be multiplying 2003 times 8 times 29, and I'm going to get $464,696. So that's the amount that I'm going to have after 10 years. So it asked me how much would I have to invest at an interest rate of my month percent. So again, my I value is going to be equal to 29%, compounded monthly to get that amount. So my t value is going to be 10 years, and my n value is going to be 12 because it is compounded monthly. So basically, I'm going to use the same compound interest equation that I used earlier, only it's rearranged to be P equals A divided by 1 plus I over divided by N, enclosed in brackets, and to the power of N times T. So I substitute in my value for A that I got here by multiplying my month, my day, and my year, which is 464,696 divided by me substituting in my 0.29 for my 29% for I, and N substituting in 12 for N, and substituting in 10 for T. As a result, I get $26,466.26. So therefore, you would have $26,466.26.